Hey guys, sorry I can't be with you in class today, but the purpose of this video is to not only take you through the notes, but at the same time I'm going to have you pause in different places and go and work on your homework, similar to what we do in class when we do a few of the notes examples together, and then I'll have you do a few of the homework problems, and then we'll do a few more notes examples and so on, and I'll kind of direct you as we go. So the goal is by the time you finish the video, by the end of class, you should have completed all of your homework as well. So, you guys, please work along with me and do the calculator things that I show you, and actually think through the notes, and don't just copy them down to be copying down work, because as you know, it's not going to help you on the homework. Okay, so we're beginning a unit on exponential functions, and you should have done this a little bit back in your Algebra 2 days, but we're not really going to depend on that, to remember all of this. So first of all, we just need to talk about how do we put a lot of this in the calculator, because a lot of these problems will eventually turn into calculator applications, and so you're going to need to know how to do exponents and just different things on your calculator. So first of all, pull out your calculator and let's just practice doing some substitution on your calculator. Notice it says we want to evaluate each value, find the value of each at the given value of x. So on the first one, basically all they want us to do is plug 4.1 in for the x. So in the calculator, we want to figure out what is 3.4, but then raised to the 4.1. Now, on your calculator, it's fine to put the parentheses, but you don't have to, as long as you know how to set up an exponent. So on my calculator, I could just simply type in, 3.4, and then, for the exponent, you can just press the little caret right there, and we want to raise this to the 4.1. Enter. And let's all round the same way. So let's go to 3 decimal places. So I'm going to say 151.030. So equals 151.030. Okay. And on the next one, when you substitute in, you just need to be careful on your calculator. If I'm going to put the 25 in for x, notice the 300 is on the outside. And then you have your 1.8, and I know the way this is set up, it shows the 1.8 and then the 4 x, and in place of x, remember, we're going to put 25. The way I would type it in the calculator, especially on the Inspires, is you're going to have to type your 300, and then you're going to have to show that you want to multiply, and then actually I would just type this as just one term, as the 1.8, and then raised to the you can either do 4 times 25, or to me it's just easier to type in to the 100. So I'm going to say 300 times 1.8, and then my little caret for the exponent, 100. And the calculator should do the order of operations and do the exponents first and then multiply by 300. So we're going to end up with we're going to end up with 1.010. 1.010. Okay. So why don't you right now pause the video and go to your homework screen, or I shouldn't say homework screen, go to your homework assignment, and you'll notice what I've not only put the snips from the textbook on there, but I've also left blank, so you can actually write all of your answers and do all of your work right here on this worksheet. So for right now, why don't you do the first part of the homework, which is the number 8, 10, and 12. 8, 10, and 12, and this is simply typing these in your calculator like you did on the notes with me. So pause the video, take a few minutes, do those, and then return to the video, and we'll pick up on the next part. Okay, I noticed something that I should have mentioned in the notes on the last problem that we did in the notes. Let's see, it was sorry, it was this one right here. We wrote down this 1.010, but when we typed it in the calculator, let's see if I still have it. Do you see how at the very end there's the e to the 28? E to the 28, you realize what that means is that's an exponential notation. And what that means is move your decimal place 28 units. In this case, because it's positive 28, we're going to move our decimal 28 units to the right. So if I were to move this decimal over 28 units, my number is not 1.01, but rather it is 10101171972 and then even further that my calculator can't go. So really this is like a giant number. So I'm gonna change this to since it's such a giant number, instead of writing out all 28 digits, I think I'll just write that basically it's an infinite number. So if you need to go back and change that on a few problems in the homework, if you see that E at the end, then make sure you go ahead and do that. Okay, so the next part is a quick refresher on the graphing. Now this should completely be reviewed. We've done this several times this year. Remember that the exponential graph goes through the y-axis at 1, right? It levels off down here at the y-axis and then shoots up. And then remember the transformations. If there's a negative on the exponent, we're going to flip it across the y-axis, right? And remember how if there's a minus 3 with the x, it's going to move it to the right 3 units. So 1, 2, 3 to the right. So it's going to be that same E shape, right? Just moved to the right. And then if you have that plus 2 at the end, remember the original goes right here at 1. So if I raise the whole thing up 2, now instead of leveling off at the x-axis, it's going to level off up here at 2 and still be that same basic shape. Now what I wanted to mention to you is you'll notice in the homework for these, they're not e to the x, but rather they're 2 to the x. Well, the number e is actually approximately 2.718. So when we say e to the x, we're really saying 2.718 to the x. So really it's just a number raised to an x. And essentially any number raised to that x, any whole number raised to that x is going to be the same basic shape. So the matching that you're doing here is really just based on the different transformations. Okay, so why don't you pause the video, take a minute, and see if you can do that matching. So you're going to do the number 13 through 16 part. Alright, that says 9 through 16, and I meant 13 through 16. Sorry about that. So this should be 13 through 16. Sorry. Yeah. Okay, so hopefully you've got those graphs, the matching part. Now we're still going to be dealing with a graph, but I want to point something out. You may have noticed on that last part where I said anytime you have any kind of a whole number raised to the x, it's the same basic shape. So I want us to look at number 5 and see, is it the same if it's a fraction? So we're going to use our calculator, and we are going to fill in this table. So I have 2/3 to the x. So for this first part here, I want to figure out, well, what is 2/3? And then if I raise it to the x, or in other words, if I raise it to the -2, what's that going to give me? So on my calculator, I'm going to put in parentheses. I'm going to put in 2/3, and if you want, you can just type in 2 divided by 3, same thing. And then I'm going to raise it to the -2, and I'm going to get 9/4. Okay, so I'm going to plug in here 9/4, which we know is a little bit more than 2. And then if I plug -1 into my calculator, you can plug it in and see what you get, but you're going to get 3/2. Okay. If I plug in 0 for x, right, 2/3 to the 0 is 1. Anything to the 0 is 1. If I plug in 1, I'm going to have just 2/3, right, because 2/3 to the first. And if I plug in a 2, it's just squaring the whole thing, so it's going to become a 4/9. So let's graph these ordered pairs. So at -2, the y value is a little more than 2. So -2, a little more than 2. At -1, I'm at 1.5. At 0, I'm at 1. At 1, I'm at 2/3, so not quite up here to 1. And then at 2, I'm at 4/9, so that's a little closer to 1/2. It's kind of hard to tell. It's kind of wide, but it still kind of is going to have that exponential shape where it kind of levels off down here and then shoots up. Okay, so if you look at your homework paper and then go to the note, let's see, I think the next part of the homework is the number 17 through 21 part. So I want you to go ahead and try number 17 and 21, and you'll notice what I've done is I've kind of set up a table for you to fill in for each one, and then you can draw the graph. Okay, so just like we did those last few problems in the homework. So I'm sorry, in the notes. So go ahead and pause the video, take a minute and do that 17 and 21, and then come back to the video. Okay, so we're back in the notes, and this next part now is a no calculator part. Let's write that down. No calculator. And we're actually going to do some solving. This is probably my favorite part of the notes. I don't know why, I just like these. These are definitely classic ACT, SAT kind of questions as well. So if I want to solve an exponential equation, in other words, if I want to solve for x, but notice the x is in the exponent, all right? We're not very used to doing that. I think the textbook calls it the one-on-one method. But basically what we're going to try and do is see if we can't get the same base on both sides. So the base on the left right here is a 2. I'm going to see if I can turn this 8 into a base of 2. Well, if you think about it, isn't 8 the same as 2 to the 3rd power? So now I have a base of 2 on the right, and on the left I already had 2 to the 2x minus 1. And the one-to-one idea that the textbook talks about is basically if you can get the same base on both sides, well, the only way these expressions can be equal then is if the exponent on this side equals the exponent on this side. So once you get the same base, it's okay to ignore the base and just talk about the exponent. So 2x minus 1 has to equal 3, and then it's going to be an easy thing for you to solve from there, right? X equal 2. So again, I definitely think the solving part at the end is going to be easy for you, but you got to think about it a little bit when you're trying to get the same base. Okay, so look at the next one. Right now I have a base of 1/3 on the left, and I have a base of 27 on the right. Well, I don't really know how to change 1/3 to be a base of 27, and I don't really know how to change 27 to be a base of 1/3. So why don't I change both of them to be a base of 3? Okay, I want to change both of these to be a base of 3. Well, the 27 I know is 3 to the 3rd. Okay, 1/3 is like having a 3 to the -1, right? Because -1 just means flip it over. But then isn't that 1/3 being raised to the 2x minus 1? So what I actually have on the left, if I raise a power to a power, don't I multiply my exponents? So if I multiply -1 times 2x minus 1, I actually have 3 to the -2x plus 1, and that's supposed to equal 3 to the 3rd. Well, there it is. I've got my bases the same, so now I can just set the exponents equal. So somehow -2x plus 1 has to equal 3. So I think, let's see, -2x, if I subtract 1, is 2. and so x equals -1. Okay? So let's go one more. And the only reason I chose this one was just because I thought if maybe you saw a number like 32, you might not recognize it as a base of 2. Actually, 32 is a base of 2. So I know 2 to the third is 8. So 2 to the fourth is 16. And 2 to the fifth would be 32. Okay, so the 32 is 2 to the fifth, but because the 32 is in the denominator, that's like having a 2 to the -5. Okay, and this is supposed to equal 2 to the 2x minus 1. So again, now I've got the same base, right? Both bases of 2's. So I just look at the exponent. 2x minus 1 is supposed to equal -5. So let's see, if I add 1, I'm going to get -4. So x must be -2. Okay, so again, once you've kind of processed that, switch over to your notes. Switch over to your homework and look at the next section, which is the 23 through 26 section. So go ahead and work on all of 23 through 26. And again, it should look like the ones we did, where you're going to try and get the same base. Notice I've given you space for your work here for all of 23 through 26. So I'm not looking for just an answer of x equals 2 or x equals 5. I want to see your work. Okay? So go ahead and pause the video, work on that, and then once you finish that, come on back to the notes. Okay. The next part is going to be a calculator application. So, whoops, I'm sorry. So we're back to some calculator stuff. So pull that out. This formula, I think you've seen several times. We may have even mentioned it in this class. It's a formula for compound interest, and it always comes up when we're doing exponential functions. So basically, you need to know A represents the ending amount, or your account balance. So I'm just going to say ending amount. Okay. P stands for principal. But that means it's the amount you start with. So it's the beginning amount. Okay. R is the rate, and what we mean by that is the percentage rate, and you're going to remember you need to write that as a decimal. Okay. N is the number of times it's compounded. Number of times compounded. Okay. And then T is the time, and something to keep in mind is this is in years. Okay. So I'm going to skip down to where we have an example. Take a look at this first example. It says if 25,000 is invested, so that's our beginning amount. So there's our P at 5.5%. So there's our R. And remember, we're going to write it as a decimal, so we're going to think of it as 0.055. And because it says compounded monthly, that means our N is 12, right? Compounded monthly. If they had said compounded weekly, I would have said 42, right? Weekly would have been 42. Or if they had said quarterly, right? Quarterly, then N would have been 4. Right? So there's several numbers there to keep in mind. And then it says what is the ending balance. So I'm trying to find A. And then they say after 20 years. So there's my T. So you're going to do all of it in the calculator, but I still want to see the setup. So I'm going to say A, which is what I'm trying to find, equals P, which is 25,000. Make sure you notice I'm just filling into this formula that I gave you, right? Now I need parentheses 1 plus the fraction. So parentheses 1 plus R over N, so 0.055 over 12. And then notice the formula says to the NT, so this time it's going to be to the N is 12, T is 20, so to the 12 times 20. Okay? And if I'm trying to solve for a, you can just type this in all in one step. So let's see. I'm going to put in 25,000. And then in parentheses, I'm going to put 1 plus. And let's see, I think we have 0.055 over 12 for that fraction. So I'm going to say 0.055 divided by 12, close parentheses. And then the whole thing is being raised to the nt. So let's see, we want to raise it to the 12 times 20. I think it would be easier to just kind of do the multiplication in our head. 12 times 20 is 240, so I'm just going to raise it to the 240. So the little caret, and then, oops, I guess I did that twice. So I can delete one of them. No, I don't want to go that direction. Let's see if that works. And so we said we want to go, let's see, close parentheses first, and then to the 240. 240. Now, do I have an extra parenthesis? No, I think I'm good. I think I've got that set up the way they had asked. So I'm going to say enter and get 83658.28. 83658.28. Now, why did I only round it to 3 decimal places? Because we're talking money, right? This is saying if you invest $25,000 for 20 years, you're going to end up with 83 or 84,000. Okay. And then we've got one more formula, right? A equals. You know what? I'll tell you what. Why don't I have you go ahead and do the homework problems that are similar to this one? So if you go and look at the homework, and we're now over on, we're going to skip the 35, 36, 37 for a minute. So now we're over here on 55 and 58. Okay, 55 and 58. So go ahead and work on 55 and 58. Notice what they do when they want you to fill this in. They're saying find A. And basically, on 55, you want the principal to always be 1,500. You want the percentage rate to always be 2%. You want the time to always be 10. But they're saying, first do it when you let n equal 1, see what you get. Then let n equal 2, see what you get. Then let n equal 4, see what you get, and on out. The whole idea is they're trying to see if how many times it's being compounded is going to make much difference. And for now, don't worry about filling in this last box for continuous. Just kind of fill in the number, use the calculator, and see what you get. So go ahead and pause, take a minute, and we'll come back. Okay, so once you've got those, then let's go back to the notes, and we have one last formula that we want to talk about. So up here, the idea is you invest some money, you have a specific interest rate for a certain amount of time, and they might say it's compounded monthly or it's compounded quarterly. And what that means is that's how often they're going to add the interest back in. Okay, the more times you add interest back in, you add the money back in, the more money you're going to make. So down here, we have a new formula, and this is if you are going to not compound it once or twice or 4 times or monthly or weekly, but what if we compound it not even every day, but what if we compound it every second? So what we say is we're going to compound continuously. So this one is for if we want to compound continuously. So this one you won't be given an n number. Okay? Well, A is still your ending amount. And P is still the principal, or your beginning amount. Okay. R is still the rate, the interest rate, and it's still going to be as a decimal. T is still your time in years. Okay. And then make sure you notice the only other variable that's in this equation is an e, but it's not a variable, right? It's the number 2.718, but your calculator has an e key on it, so you don't need to type in 2.718. All right, so here's the idea on this particular problem. It says if 10,000 is invested, so there's our beginning amount, there's our principal, at 6.9%, so there's our R. Remember, we're going to write it as a decimal, so 0.069. And because it says compounded continuously, that just tells me, hey, this is the equation I'm going to use, as opposed to the one up at the top. And it says, what's the ending balance after 40 years? So I'm going to let t equal 40. Well, again, I want to see your setup. So A equals, P is 10,000, and then I need E, the actual function E, to the RT. So I'm going to raise it to the power of 0.069 times 40. Okay, so let's put that in our calculator. 10,000. I'm going to say times, and then on the calculator, the E is control, well, you see the e to the x kind of right over here next to the 10 to the x, so E, and it'll automatically pop up a space there to put in your exponent. So I want 40 times 0.069. So I'm going to put in there 40 times 0.069. Okay, and then when I press enter, that means, now notice the E at the end, so you're going to move this decimal over 17 places. Okay, is it an infinite amount? Well, if I move it over 15, or if I move it over 17 places, it's definitely all of those numbers. So as far as I'm concerned, that's pretty infinite. I mean, if I want to think about it in terms of actual dollars, well, this would be a crazy amount. Let's see, I would have 1531723 1531723 and then what do I have? 3557. Remember, the decimal was originally right here, so I've moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved it 11 places, and because this said e to the 17th, if I've moved it 11 places, then technically I need to move it 6 more places. So that's like adding on 6 more zeros to this. So if I add on 6 more zeros, 1, 2, 3, 4, 5, 6. I mean, think about how much money. There I am, hundreds, thousands, millions, billions, trillions, quadrillions. So this is 153 quadrillion dollars. Interesting. Okay, so why don't you go ahead now back to your homework. Oops. And you have those last few problems. Notice each of these say compounded continuously. Here we are, compounded continuously. So that's how you know you're going to use that last formula. And I'm going to go ahead and say this right now. Number 71 does not use those formulas. It's still about exponential. I just want you to look at it, read through it, and try it. Do not leave this blank. Do not come to me the next day saying, I have no idea. Try something and see what you think. All right? So make sure you get those last ones finished, and then I'll be taking a grade on this during the next class period. So good luck on that.